Application. Application involving problems. Okay, we have learned in chapter 5, I think. Okay, in chapter 5, we learned how to set up a quadratic equation. Right? That's not open. Okay, we learn how to set up a quadratic equation and how do we solve for that and choose a suitable domain. Okay, so what we're going to do today is very similar. Okay, we want to apply quadratics to solve problems may involve, okay, we need to define the variable, forming the variable, solving the equations, deciding a suitable range for the variable, and sketching the graph for any key points, and then find maximum or minimum of the turning point. Okay, you may be asking for all of that in one application question. That's all the abilities you need to know for an application question. So let's just have a look at the example here. A piece of wire measuring 100 centimeters in length is bent into the shape of a rectangle. Okay, you have 100 centimeters in total and it's bent in a rectangle. Let X be the width of the rectangle. Okay, be the width of the rectangle. Let the perimeter to use the perimeter to write an expression for the length of the rectangle in terms of X. Okay, so perimeter. Length of the rectangle. So you have the width to be X. Okay, let's just draw a rectangle. Okay, so that's a rectangle. We have width of X. And you know everything in total add up should give you 100. What do you think the length will be? What do you think the length will be? Everything add together will be 100. Width is X. What is the length? How do we write perimeter? If that's X, that will be X as well. Okay, let's say that's the length. That's the length. For A, we have length plus X must be 100. 2 length plus 2X will be 100. Length plus X will be 50. Length will be 50 minus X. Okay, that's how we find the relationship between the length and the width. Okay, length plus width. Okay, 1 length and 1 width will be 50 because 2 length and 2 width will be 100. Okay, so 1 length and 1 width will be 50. So if width is X already, length will be 50 minus X. B. Write an equation for the area of the rectangle in terms of X. You know the rectangle's area will change according to the length and width. For example, we can have a shape like that. We can have a really long one. I can make here to be 40, here to be 10. Okay, this area will be 50. But I can also make another rectangle with 30 and 20. That can that's a 400 of the area. That's a 600 of the area. So you can see by different pyramid, like different shape, like using different lengths and widths, you have different area. So I want to write an equation how the area is changing when the X is changed. Area will become length times width. Area will be 50 minus X times the X. Okay, 50 minus X times the X. Or I can also say that's a minus X squared plus 50X in the factorized form, in the expansion form. Minus X squared plus 50X. Okay, for C, what do you think will be a suitable value for x? What do you think is suitable for value of x? Can x be negative? No. Can x be 100? Okay, it can't be too large, it can't be too small. So what will be the boundary values? Less than 50 and greater than 0. Okay, needs to be greater than 0 or less than 50. So you can use two things to set up that. What you can have? You can have first, x represent the width. That width must be greater than 0. Second, 50 minus x represent the length. The length needs to be greater than 0 as well. Okay, both length and width needs to be greater than 0. And then we can find a rectangle shape. So we solve that. We have x, well, we solve the bottom one. We have x less than 50. Plus, you need x than 0. So overall, I need to write x is in between 0 to 50. But not including 0, not including 50. Why not including them? Because if equals to 0 or equals to 50, there's no area, there's no rectangle has been made. It's not a rectangle anymore. Okay, let's see. So your x can only be suitable in between 0 to 50. Okay, in between 0 to 50. You can't say x equals to 60. What is the area? It's not really making sense. Okay, have a look at D. Sketch the graph of A versus x. Okay, for the suitable value of x. Okay, for the suitable value of x. So your x suitable in between 0 to 50. Your graph will be in between 0 to 50. You can't sketch a full graph of the quadratic. So first, let's have a think. We have three ways of sketching quadratic graph. We have intercept form, we have turning point form, and we have a quadratic formula. Which way you want to sketch the a and x? Which x-intercept form? Because we have the factorized form already. Okay, that's the factorized form. So let's sketch that. Alright, what I will have is 0 is here, 50 is here. And you can see from that equation, you will have when x equals to 0, that's 0. When x equals to 50, that's 0. So you need to have two open circles on 0 and 50. It's not going to be closed circle. You will have open circle. Why? You can't take 0, can't take 50. You can't have those 2 points. That is where your start point and finish point, but you can't take those 2 points. Okay, I find my x-intercept. Then I'm looking for the middle. Where is the middle? Okay, we have 0, we have 50. Where is the middle? Where's the middle, everyone? 25. Okay, so 25. So my turning point must exist on this line. Okay, on this line. Okay, it must be on this line. So it's 25. Okay, it's 25. Then I will say when x equals to 25, a equals to 50 minus 25 and times 25. That's 25 times 25. That's 625. That's 625. Let's say we have a point here with a 625. So the shape of the graph is like that. Okay, it's like that. You label that point as 25, 625. That is an open circle at 50, 0. That's an open circle at 0, 0. The graph can continue below, but I'm not going to sketch it because it's out of the proper domain. You can't have negative area, okay? You can't have negative area. You can't have negative x, which is the width. So my graph will stay in between 0 to 15. Okay, stay in between 0 to 15. A, B, C, that's D. That's D. Okay, E and F, they are talking about the same thing. E, it says, use the graph to determine the maximum area can be formed. The maximum area I can see is the maximum turning point, which is 6 to 5 centimeter square or meter square, centimeter squared. And the dimension, when we achieve this area, dimension is when x equals to 25, A max is 6 to 5. So your width is actually 25. Then you can find the length. So I will answer E and F together. Okay, I will answer E and F here. When x equals to 25, which is the width, A max equals to 6 to 5 centimeters squared. Okay, then length equals to 15 minus 25. Length equals to 25 centimeter as well. Then the dimension is 25 centimeter times 25 centimeter. And that will give you a maximum area at 6 to 5. Will give you a maximum area at 6 to 5. Okay, that's how we do application questions. Well, there's nothing new about application. It's all the same. But you set up equation and you give a meaning to the variable. So there will be some restrictions on your variable. For example, time. For example, the amount of money, the area, the volume, the length, the width, they all can't be negative. And then normally your graph will be only in the first domain, first quadrant. Okay, only in the first quadrant. So you won't have like negative values on the second, third, and fourth quadrants. So that's for application question. You can just try some application question on the textbook, and I think that will be enough for you. Okay, so I will stop here today, and tomorrow we'll finish the 7G. Okay, we'll finish 7G. Yep. No, we'll skip that. We'll leave that to next year first topic. That will be this chapter.